Yes. So previous video I am started the conic section of the ellipse part 1. In that the basic questions are there, and part 2 I am going to explain today 7 to 8 designs which are frequently coming in EAPCET point of view. And one more very important is, in EAPCET ellipse we can expect 2 questions, but in that one we can drive directly without any effort. But the second question will be, every question you have to calculation will be more than the application. So don't say that it is a time waste, but by using the formula lines in a quick way you can able to answer both the questions. So please remember, this is the question started in the second video, the 6th one. Read what is the given. An ellipse has its major axis along y-axis and minor axis along x-axis. Means what? The ellipse is coming like this. So major axis along y-axis and minor axis along x-axis. So this is what we got in this. A square is less than b square. A is less than b. A is less than b case. So an ellipse has its major axis is along y-axis and minor axis is along x-axis. If its length of lattice rectum is 2 by 3 times of its minor axis, then what is its eccentricity? This is the way. So length of lattice rectum is 2 by 3 into its minor axis. Length of lattice rectum for normal or standard, yesterday previous video I am explained 2b square by a whenever a is greater than b. But a is less than b, it is coming 2a square by b equal to 2 by 3 into length of minor axis is 2a. Now the 2 and 2 cancel, 1a and 1a cancel, you are getting a equal to 2b by 3, one relation. Since actually when a is greater than b, the eccentric value is b square equal to a square into 1 minus e square. Because here a less than b, the eccentricity format comes a square equal to b square into 1 minus e square. In that, a square is 2b by 3 whole square means 4b square by 9. Equal right side, b square cancel. We will get the required eccentricity will be root 5 by 3. The option C is matching here. This is the first question. Next, the design number 7. A focus of an ellipse having eccentricity 1 by 2 is at 0, 0. And one of its directrices is the line x equal to 4, then what is the equation of such ellipse? Here there are 3 conditions are given. One is, normally for ellipse, a double focus and double directrix will be exist. One of the focus is 0, 0 at origin they are given, and one directrix is x equal to 4 is given, and also eccentricity is 1 by 2. So the focus S is 0, 0 and eccentricity is 1 by 2. Now the focus and eccentricity is there. One more is there in between. What is the equation of directrix? Directrix is also there. Equation of directrix, x minus 4 equal to 0. Whenever on a ellipse, please see that, suppose if you want to construct an ellipse, this is the directrix L and L dash. On this you can select a point on it. P is a point on it such that one of the focus S is PM. SP by PM equal to E. SP by PM equal to E. This is the concept behind whenever the focus and directrix are given. So focus and directrix with eccentricity is given. So assume a point Px1 by 1 be a point on the required ellipse such that by definition of conic ellipse, SP by PM equal to E, SP square equal to E square PM square. SP is the distance between the focus and the assumed point. X1 minus 0 whole square plus y1 minus 0 whole square equal to E is 1 by 2 given, substitute 1 by 4, and PM is what? The perpendicular distance from point to the directrix. Mod of 0 minus 4 and formalities, it comes by cross multiplication, it comes what? 3x1 square plus 8x1 plus 4y1 square equal to 16 by squaring on both sides. Correct? Actually it is coming square root squaring on both sides. So by simplification you are getting as it comes 3x1 square plus 8x1 plus 4y1 square equal to 16. You have to standardize it. Take the 3 common and it can be manipulated to ax. So this 4 by 3 can be add and square, subtract, square and add. So 16 by 9 minus 16 by 9. Then these 3 terms are coming as x1 plus 4 by 3 whole square, remaining part as it is. From this we can make it as an LCM and do it and send 3 inside, multiply with this. Here 3 square is there, 1 3 cancel, 3x1 plus 4 whole square by 3. These 2 terms as it is, multiply the entire equation with 3, then this comes 3x1 plus 4 whole square plus 12y1 square equal to 64, which is exactly match the option D. This is the design number 7. Next design number 8. Next 8th design, the eccentricity of an ellipse is passing through 3 root 2 comma root 10 with foci at minus 40 and 40 is given. They are asking eccentricity. The question is given, ellipse passing point and foci is given. Let you can create a dummy equation of the ellipse. Let equation of ellipse is x square by a square plus y square by b square equal to 1. Condition number 1. Since it is passing through 3 root 2 comma root 10, wherever x you can keep 3 root 2. 3 root 2 whole square means 18 by a square plus root 10 whole square is 10 by b square equal to 1, that is 1. Given the foci S is plus or minus 4 comma 0. Distance between foci is SS dash equal to 2AE. But 2AE equal to 4 plus 4 8, AE equal to 4. A square E square equal to 16. This you can keep it as number 2. But according to the concept of the eccentricity, A square equal to, we can write and a square e square in terms of b square, a square into 1 minus b square by a square equal to 16. From this you can elevate b square equal to a square minus 16. This is 3. Now you observe that one from 1 and 3. Wherever b square you can keep a square minus 16. So entire equation is coming as biquadratic of a, that is coming a power 4 minus 44 a square plus 288 equal 0. By factorization it comes a square minus 36 into a square minus 8 equal 0. So either a square equal to 36 or a square equal to 8. Suppose you are taken as a square equal to 36 from equation 2, what we are managed here. A square e square is 16, a square is 36, you are posted e square equal to 16, e square equal to 16 by 36, but that is what you can cancel 4. 4 fours and 9 fours, 4 by 9 under root it comes 2 by 3. The option is B matching. 1 minute. Sometimes a question comes, sir, you are selected 36, sir, a square 8 also we can manage. Suppose a square is 8, you are taken as 16 by 8, e will be coming root 2. No option is matching. That's why a square equal 36, the only option is matching here. And this is the one design, is a very, very important design. The area of the quadrilateral formed by joining the 4 foci points of 2 ellipse equations given. Options are given. Now you observe what is actually they are asking. If you observe these 2 are 2 inverse designs of the ellipse. One is x square by a square plus y square by b square equal to 1, a is greater than b. Another is a less than b. So one is like this and another is like this. Double foci will be there for first and double foci for second. If you are attach all the 4 foci points that gives the quadrilateral ABCD, then they are asking what is the area of the quadrilateral. You have done that one. Let ellipse 1 x square by 9 plus y square by 5 equal to 1. A is 3, b is root 5. Eccentricity is, since here a is greater than b, root of a square minus b square by a square, calculation 2 by 3. And the foci is plus or minus a comma 0 plus or minus 2 comma 0. So one point of the foci is 2 comma 0. Second for that pair is minus 2 comma 0. Similarly, you can apply for second ellipse, but in this very important is a less than b. That's why a is root 5, b is 3. Eccentricity formula is coming root of b square minus a square by b square, which is equal to 2 by 3. That is what eccentricity for both the ellipse are same. But foci is, because on the y axis, so 0 plus or minus b, 0 plus or minus 2. So the double foci will be, I identify the letters C 0 2, D 0 minus 2. Now the question comes, what is the area of the ABCD? This is say ABCD, whatever. Area of the quadrilateral ABCD means half AB into CD. Half AB is 4 units, CD is 4 units, that 8 will be matching the option D. Next design is connected to the ninth one. Previous question, what is the area of quadrilateral we are keeping? Now, what is the area of the greatest rectangle that can be inscribed in a standard ellipse? So, from diagramic approach you can see, take the x and y axis, C will be the center, and ellipse we can inscribe the ABCD is a quadrilateral. To get a maximum, what is the conditions? Given ellipse is x square by a square plus y square by b square equal to 1, let parametric points on it are, parametric point on the ellipse is x equal to plus or minus a cos theta, y equal to plus or minus b sin theta. Thus 4 vertices points on it are first quadrant A, second quadrant B, third in C, fourth in D. That's why P will be take, instead of ABCDs you can say 1 minute, PQRS. Yes, PQRS. Yes, P is A cos theta, B sin theta, both are positive first quadrant. Q is in second quadrant, X negative, Y positive. R is in third quadrant, both are negatives. And S is in fourth quadrant, X is positive, Y is negative. Once you got PQRS, area of the rectangle, not ABCD, I am changing this one, PQRS. PQRS. So area of the rectangle PQRS will be PQ and these two are equal, length into breadth. So 2a cos theta into 2b sin theta. So 4ab sin theta cos theta, I am matching the 2ab outside and the remaining is standard trigonometric format. 2 sin theta cos theta will be the sin 2 theta. Depend upon the theta, the area will be fluctuated or variate, because their question is very restricted as what is the maximum or greatest. To obtain area of the rectangle is maximum, this should be 1, because sin of anything is maximum is 1, that gives the maximum value. So theta should be 45, sin 2 45 or sin 90 is 1, 2ab. So which option is matching? Option D is matching. Then next is also a very repeated and important design. It is an application of the trigonometry problem. If theta is an angle made by the common tangent to the circle and ellipse with positive x-axis, then what will be the cos 2 theta value? Here you observe that one, there is a ellipse is given like this and some circle is given somewhere if I draw like that. Then we want to find out a common tangent like this. But both are have the center is 0 0. It is concentric diagram you can draw. Roughly I am explaining the concept. First write given circle x square plus y square equal to 16. From that the center is 0 0 and radius is 4 units. Similarly, given standard ellipse is x square by 25 plus y square by 9 equal to 1. A square is 25 and b square is 9. Always connect, a is greater than b. Now a common tangent equation is our requirement. Let equation of common tangent be y equal to mx plus c. This is the third. If this common tangent is touches the circle, condition you must remember, c equal to r into 1 plus m square. Whenever a line y equal to mx plus c is a tangent to the circle, standard, condition is c equal to r into root 1 plus m square. C equal r is radius, remaining as it is, that will be the fourth. Same way, if the line is also touches the ellipse, condition is c equal to root a square m square plus b square. C equal to 25 m square plus 9, that is a 5. But you observe that when left sides are equal, equate the right sides. From 4 and 5, we are getting a quadratic equation in m square. So m square equal to 7 by 9. M is root 7 by 9. M is what? Is tangent, is the slope of tangent, is the slope of tangent. Slope of tangent. So m equal tan theta, that gives root 7 by 9. But actually they are asking the question cos 2 theta. By trigonometric multiple submultiple way, cos 2 theta equal to, we know that 1 minus tan square theta by 1 plus tan square theta. Substitute this, we are going to get cos 2 theta value is 1 by 8, means option D is matching. A repeated design of the like 11th, a common tangent for ellipse and circle. The equation of common tangent to the given circle and ellipse will be what? First, write the given circle and write center 0, 0 and radius 2 like previous. Ellipse is given and a square and b square identify. Let equation of the common tangent to assume in a slope form is y equal to mx plus c. If it touches the circle, condition is y equal to mx plus or minus r into root 1 plus m square. With this we are getting as the fourth equation. Similarly repeat, if the line 3 or common tangent is also touches the ellipse, condition is y equal to mx plus or minus root a square m square plus b square. Fifth is got. Right side equate fourth and fifth we are getting as m value. That m value substitute either fourth or fifth, that gives the equation of ellipse, and simplify that one and match the option B will be coming. With this the conic section is ended. Next I am going to take the definite and indefinite integrals. Thank you very much. And one more request to all my dear students, please subscribe the My Dream Academy channel and share to your friends. If you like this video, and make a comments also better, and we hope that I will expected more number of videos from our side. Thank you.